Let's continue section 1.2, solving linear equations. This example is how to solve consecutive integer problems. Consecutive integers are numbers that go in order. And so as you can see in the graphic, 1, 2, 3, 4, 5, 8, 9, 10, 11, 23, 24, 25, 26. You can even have negative numbers like negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So this first question, the sum of three consecutive integers is 531. What are the three integers? So we're looking for three numbers that add up together to give us 531, and they are in order. So we're going to give the first number the variable n, and the number that comes after n in order is n plus 1. So we're going to add n plus 1, that's the second number, and then we're going to add the number that comes after that because there are three numbers. So blue is the first number, red is the second number, and the third number is going to be one more than the last number that we had. So what's one more than 1? 2. Okay, so think of it as like if we plugged in the number 1 into n. You don't need to write this down, I'm going to erase it after, but if you put 1 here, the next number would be 1 plus 1, and the next number would be 1 plus 2. So that would give us 1 plus 2 plus 3, and you can see that they're in order. We're just adding 1 to the number in front of it, gives us the next number. Okay, so you can put parentheses around each number if you'd like, so that you know that they are three numbers, even though it looks like n plus 1 is two numbers. It's really one number. Equals 531. So now we can collect like terms. We have n, 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 so that will be 3n. And we have 1 and 2, so that's plus 1 plus 2, which is just 3, equals 531. Now we have a two-step equation. We're going to solve this like we've been solving our equations. Minus 3 from both sides. And you get 528. These 3's cancel. 3n equals 528. And our next step is we will divide by 3 on both sides. And I'm just going to bring this up here to finish solving. These 3's cancel out, leaving us with n equals, let me see, do some division. If you want, you can put that into your calculator. 528 divided by 3. 3 goes into 5 ones, 2 remaining goes into 7, 6. Check my work there. So that just gives us the first number. Remember the just n number. We also need the n plus 1, and we also need the n plus 2. Well, if n is 176, what's the next number? And if n plus 1 was 177, what's n plus 2? The next number. And if you add these up, you should get 531. Let's check our work. 15 plus 6, 21, carry the 2, 21, 22, 23, and carry the 2, 531, and that's what we started with, 531. So those are the three consecutive integers. The sum of four consecutive integers, the sum of four consecutive odd numbers is 64. What are the four integers? So that means we're going to follow the same thing that we had before, but just a little bit different. We have the first number n. Let's say n is 1. What would the next odd number be? 3. And the next number after that, 5. Well, how would you get from 1 to 3? We add 2. And how would you get from 3 to 5? You add 2. So then each time we're counting by odds, you're going to add 2. So then the next number, if we add 2 to that, would be 4. And you can test it. So let's work this out. It's going to equal 64. The sum of four consecutive, hold up, 4 consecutive odd numbers. We only have 3, so we need to add another one. That's going to be plus 6, because another 2 equals 64. So we have 4 n's, and we have 2 plus 4 is 6, plus 6 is 12, equals 64. So now we have a two-step equation that we're going to solve. The first step is to subtract 12 from both sides. For n equals 52. The next step is to divide by 4. The 4's cancel. N equals, 4 goes into 5 once, so 13. The next number is going to be n plus 2, which is 15. And the number after that is going to be n plus 4. So that would be 13 plus 4, which is 17. And n plus 6, that's going to be 2 more, which is 19. You can add those up to check to see that they equal 64. And let's just do that really quick. 9 plus 7 is 16. Plus 5 is 21. Plus 3 is 24, and yes, it checks. Solve or use linear equations to solve mixture problems. If a lab technician needs 30 liters of a 25% acid solution, how many liters of a 10% solution and a 30% solution should she mix to get what she needs? I'm sorry, I should have done that in a different color. So we have 30 liters of a 25% solution. That's what we want. So we're going to get 30 liters of 25% solution. And we have, let me just get this to be the same color. How many liters, so we'll use X for that, of a 10% solution. And if we're already using, if we have 20, that we want 30 liters, and we're already going to have X amount from the 10% solution, then we're going to have to take away the X from the 30 liters. So we have 30 liters, and we're going to have to take away X from that before we multiply it by the 30% solution. okay? And these are going to be added together, the 10% solution and the 30% solution, to equal 30 liters of a 25% solution. All right, let's work this out. So 30 liters of a 25% solution, we are going to write that as the percent into a decimal, 0.25, and we're going to multiply it using parentheses, 30, and then we're going to have the 10% solution we'll write as a decimal, 0.10, and we're going to multiply it times x, and then we're going to take the 30%, write it as a decimal, 0.30, and we're going to multiply it by the 30 minus x. Okay, let's put in our pluses and equals. So how would we solve this equation for x? I'm going to use the method where we distribute first, because this green part is a little bit messy for me. So we are going to distribute the 30%. That's going to be my first step to solving this equation. 30 times 0.3 is going to be 9. And then 0.3 times x is going to be 0.3x. And then we'll just bring down the 0.9 or the 0.10x. And I can go ahead and multiply this here in this step as well, because it's on the other side of the equation. So a quarter of 30 is 7.5. And you can just use your calculator if you'd like. So we have to combine, this is our second step, combine like terms. 0.10x and minus 0.3x become negative 0.2x. So that's the 10% and the minus 30% is minus 20%. Plus 9, we're just bringing that 9 down, equals 7.5. Now it's okay that the x is on the right side of the equation. We need to learn how to work back and forth from if it's on the right side or the left side. And we can solve for x wherever it's at. The next step will be to solve for x by subtracting 9 on each side. This is the third step. And from there we get 9 minus 7 is 2, minus 0.5, it's going to be negative 1.5 equals, the 9's cancel, bring down the negative 0.2x. And then we need to divide, and since we're dividing by a negative 0.2, a negative divided by a negative is going to be a positive. So in your calculator, you can just stop worrying about the negatives and just do 1.5 divided by 0.2. Okay, so 1.5 divided by 0.2. Don't leave out your decimals. So we get from that, sorry about that, this is the fourth step over here, is dividing by negative 0.2. We get 7.5 equals x. Well, what is x? We have to take that x and plug it back into our problem. So what does that mean? 7.5 is equal to x. and that represents the number of liters of the 10% solution. So X of the 10% solution. So how much do we need of the 30% solution? If you remember back up here in the beginning, we said it was going to be 30 minus X. So if X is 7.5, then we need to do 30 minus 7.5. And that's going to give us 22.5 liters of 30%. And so we should add right here 7.5 liters of the 10% solution. Okay. On to our next problem. Those mixture problems are tricky, so we'll have plenty of practice with that. And feel free to watch this video again. It's on your Canvas. Solve work and time problems. Keenan will run 2.5 miles from his house to Jared's house. He plans to hang out for 45 minutes before walking home. How long will he be gone from home? Okay, so his friend's house is 2.5 miles away because it says right here he's going to run 2.5 miles to Jared's house. When he is running, he runs at 6 miles per hour, and he's going to stay there for 45 minutes. So we want to know how long will he be gone from home. If he is running 6 miles per hour, and he's running 2.5 miles, then we have to divide by 2.5 miles. And I'm not sure if you've learned dimensional analysis, but this cancels out the miles, leaving us with just hours. Okay, so that's how long it's going to take him to run that far. And then he plans to hang out for 45 minutes. So he stays there for 45 minutes, which we're going to need to convert into hours for this all to work out. Plus, he's going to have to walk home. That's what it says in the problem. He walks home, and walking is 4 miles per hour. So 4 miles per hour divided by, how far is it? It's the same distance back to his house, 2.5 miles. All right, now we need to do some calculations and take care of that minutes and put it into hours. So 45 minutes is 3/4 of an hour. Think about it. Half an hour is 30 minutes, and half of 30 minutes is 15. So every 15 minutes is a 1/4 hour. 15, 30, 45, that's 3/4 of an hour. So we can leave it as a fraction, 3/4 of an hour, or we can change it to a decimal. 3/4 is 75 cents, so 3/4 is 0.75 hours. 6 divided by 2.5, let's do that on our calculator. 6 divided by 2.5, and you get 2.4. So it's going to take him, after we do that division, 2.4 hours to run, plus the amount of time he stays at Jared's house, plus 4 divided by 2.5. Is 1.6. And now we just need to add those together to figure out how long does he stay there. And we'll use the variable t to figure this out. So go ahead and add those numbers up. and you get 4.75, or 4 3/4 hours, 4 and 45 minutes, is equal to the time that he stays at Jared's house.